I'm going to talk about the basics of parallel and perpendicular lines. I'll get into writing equations of parallel and perpendicular lines in a later video. So when we're talking about parallel and perpendicular lines, I think it helps to first see visually what's going on before I just kind of give you the things you need to know as far as algebra is concerned. So we're just going to start by graphing these two linear equations, or these two equations of lines, on the graph here. So, and I'm going to assume that you're pretty good with this, so I'm going to go through this kind of quickly. If we graph the first one, we'll start at a y-intercept of -1. We're going to rise 2, run 1, rise 2, run 1, rise 2, run 1, go down and back. And that would be a nice little picture of what our line would look like for that red line there. We're going to try the one in blue now. So again, we'll start up at now a y-intercept of 3. We're going to rise 2, run 1, rise 2, run 1, go down 2 and back 1. And you can see here that what we have are two lines that are parallel. Okay, so these two lines that I've drawn here, they're never going to cross. Remember that parallel lines are lines that will never cross. They'll go on forever and never intersect. Okay, you might have a reason that you would think these two are parallel, and the reason is if you look carefully here that your parallel lines have the same slope. Okay, so these two lines have a slope of 2. That means that they are going to be parallel. Now you have to be careful. You know, if you have a line like, let's try something like this. If you have a line like 2x minus y is equal to 10, if it's not in slope-intercept form, remember that this 2 here may not be the slope that you're looking at. Okay, you might have to isolate the y first to get it so that you are looking at the slope of the line. Okay, so you might have to isolate that first to get it so that it does have a slope of 2. And in this case, this line still would have a slope of 2, but it's possible you might be looking at something that's not technically your slope. Okay, so if it's not in slope-intercept form, make sure you get it there. I'll show an example with that later. Okay, next one. So we're going to talk about another type of lines here, perpendicular lines. And for this line, I'll do this in blue. We'll start at -2, and we'll rise 1 and run 3. Should be going uphill from left to right. And now I'm going to go ahead and extend my line here. So that takes care of the blue line. And the red lines. We got up here at 6. 1, 2, 3, 4, 5, 6. And this line will be going down 3 and over 1. Down 3 and over 1. Down 3 and over 1. And you can see here that these two lines, and this isn't like a formal proof or a formal way of saying this, but these two lines seem to cross at a right angle. That means they're perpendicular. So lines that cross at a perfect right angle are perpendicular. And again, when I say right angle, I just mean 90 degrees. Not a whole lot you need to know about that in algebra. That's a lot bigger topic in geometry. But for now, we'll talk about how we can tell that these two are perpendicular. When you look at the slopes, okay, this one's a little harder to see. The way that we talk about perpendicular lines is they're opposite reciprocals, meaning if you took the reciprocal of 1/3, you'd get 3. And since this is a positive 1/3, if we took the opposite of it, it'd be negative. So if you flipped 1/3 and you switch the sign, you should get the other slope. And if that's the case, then they're perpendicular. Okay. So some quick notes on these. Again, the important thing to get here is that parallel lines have the same slope. Okay. Yeah, this should say perpendicular. Let me fix this real quick. So the slope of perpendicular lines, I'll abbreviate here. The slopes of perpendicular lines will always be opposite reciprocals of each other, or if you flip the one slope and switch the sign, you should get the other slope. So again, you can see these two are going to be parallel because they have the same slope, or the same number in front of x when they're in slope-intercept form. These two numbers here, if you flip -2/3 and switch the sign, well, if we flip it, we get 3/2, and it is negative, so we'll flip the sign, make it positive, you get the slope of the other line. That means that these two lines, if you were to graph them, would be perpendicular. And these two lines, oops, it should actually be going downhill. These two lines, if you graph them, should be parallel. Okay, so let's look at a few examples how we can kind of identify some slopes. Again, I'm not going to get into an equation today. I'll do that in the next video. So parallel to y equals 3x plus 4. We're trying to find the slope of a line, or any line, that's parallel to y equals 3x plus 4. So I'm not looking for the equation of a line, just the slope. We know that if it's parallel, well, it's got to have the same slope. So in this case, if it's parallel and it has a slope of 3, then any line that's parallel to that also needs to have a slope of 3. That takes care of number 1. Number 2, perpendicular to y equals 4x minus 60. So if I want to find a line that would be perpendicular to that line, I've got to flip this slope, or take the opposite reciprocal. I've got to flip 4, which if we flip 4, 4 over 1 becomes 1/4. And since it's positive, I have to switch the sign and make it negative. Again, opposite reciprocal, or flip it and switch the sign. Okay, so that'll take care of the next one. Parallel to 2x plus 4y equals 8. Okay, once again here, I can go ahead and start. If I try to just make this 2, that's not necessarily going to work. So we need to make sure this is in slope-intercept form, so we know that we're looking at the slope first. So this will give me 4y equals negative 2x plus 8. And if I divide by 4 through each of these, you'll get y is equal to negative 1/2 x plus 2. So now we know that we're looking at the slope, and since it's parallel, well, we're just going to keep the same slope. We don't have to flip anything or switch the sign. So our slope here would be negative 1/2. Okay, so any line parallel to this line here, 2x plus 4y equals 8, should have a slope of negative 1/2. Almost there. Now this next one, you might get thrown off by this 90,000 here, or that could really be a pi, it could be whatever. You're going to find that this y-intercept here isn't super helpful when we just want to find the slope of a parallel or perpendicular line. So I'll show you what I mean in a second. So I'll move the 5x over. I need to get the y by itself first, so that gives me negative 2y minus 5x is equal to 90,000. Oops, not equal to, sorry about that. That should be a plus sign, so plus 90,000. And then from here, we're going to have to divide everything by negative 2. And again, you can punch that in your calculator. It's not that hard to divide that. But when you're doing this, if you go ahead and really all we need from this is the slope. So if we look at that, that's going to give us a positive 5/2 for the slope. And when we do that, if we're looking for a perpendicular line, we're going to have to flip it and switch the sign. So this would be a 2/5, and the opposite reciprocal would be negative 2/5. Okay, so that should get us the answer to that one. A little more work on the perpendicular problems, not a whole lot more, but you have to go one extra step to find the opposite reciprocal. Okay, now these types of problems we'll put little stars by, because you got to be careful on these. Okay, these are ones you should look out for. If you're looking for a line parallel to y equals 4, you can do this using the equation. I'm going to actually explain this just using a little bit of logic, looking at a graph. Okay, and if we were to actually kind of look at the graph of y equals 4, it would go straight across here like this. Okay, if you're looking at a line that's like this is a horizontal line. It has just a y. We said that those look like the horizon. I think we said that in a previous video. So this line is horizontal. Okay. We know that horizontal lines don't have any steepness. They have a slope of 0. They're not steep at all. So the slope of any line parallel to that would also have a slope of 0. It also have to be a horizontal line. So that takes care of number 5. Finally, if we're looking for a perpendicular line, that means it must cross at a right angle. And you might be able to tell what kind of line this is just by looking at it. This is a vertical line. Okay, so if you have a horizontal line, something perpendicular to that must be a vertical line. And we said that vertical lines are like skiing off a cliff. They're so steep that they don't have any slope, or we can't even measure their steepness. So the slope of this line would be no slope, or probably a better way to write that would be that the slope would be undefined. Okay, so the slope of any line perpendicular to a horizontal line would be undefined. And that's just a quick little introduction to parallel and perpendicular lines. Again, in the next video, I'm going to go ahead and work through these and try to write the equation of the lines given certain information that we'll have.